Yeah, hello. So guys, continuing with trigonometry. Today we are going to be focusing on angle of elevation and the angle of depression. And from there we are going to do the cosine and sine rule. And then you know that and another thing, please check on your textbooks if you have cosine and sine rules, because I was thinking that in this video I could do angle of elevation and angle of depression. Then after you've told me whether you do have cosine and sine rule, then we can go ahead, because I think they're in grade 11, but yeah, I don't remember quite well. So if they're in grade 10, please tell me so that we can do them. I'll see if we'll cover them, or I'll just cover angle of angle elevation and depression only. Then from there you tell me whether you do have those in your textbook, the cosine and sine rule. And then on the last video, and another thing, guys, please be quick. Once you finish a video, get back to me as quickly as you can, because you can't take time. You can't be watching one lesson for the whole week, right? So I'm not rushing, but you must be fast, right? Because time is against us. So the last video will be doing the graphs. So I wanted to do the graphs separately. The last video we do, or the last lesson we do on trigonometry will be in graphs, right? So without wasting time, we have, don't mind these mixed problems, right? This is simply angle of elevation and depression. And what I want you to understand before you can even confuse yourself is the weights are self-explanatory. When you elevate something, you take it, you lift it up, right? When you depress something, you press it down. That's as simple as it is. You elevate, you lift it up, you depress it, you push it down. Simple as it is. So what I want you to understand is that you remember when I first introduced trigonometry and everything, I told you that when it comes to maths, we count angles going anti-clockwise, right? We go in that direction, anti-clockwise. We don't go clockwise, right? So when we go anti-clockwise, it means that if we want to do the I just want to explain this concept of angle of elevation and depression. Already you know that when you elevate, you lift it up. In simplest terms, when you depress, you push it down. So when you elevate, since we move in anti-clockwise direction when we count angles, it means that if I move from there and then I go up until there, what have I done? I have elevated because I've pushed this upwards, right? Meaning that when I depress the angle, I'm going in the opposite direction, right? So automatically, what we know is that when we count angles, we go in an anti-clockwise direction, right? But when, meaning that all the angles, when you go in an anti-clockwise direction, those will be your elevation, angles of elevation. But when you go clockwise, meaning that when you start here and then you go like the clock goes clockwise, those will be your angle of depression, right? I hope that makes sense. We go anti-clockwise, that's your elevation. But another simplest way to remember it is that if I go from there and then from there, what have I done? I have lifted it up. If this is your angle there, I have lifted it up, right? But if I'm depressing it, moving from there maybe to somewhere there, what have I done? I have depressed the angle. I have depressed the angle because you can see this one is upper, this one is lower. So I hope you understand. When you go anti-clockwise, it's your angle of elevation. When you go clockwise, it's your angle of depression. I hope that makes sense, guys. So without wasting any more time, let's dive in. When you look up at something, when you look up, that's a key word. When you look up at something, such as an aeroplane, what do? You lift your head. So this is an angle of elevation because you're looking up. The angle between your line of sight, your angle between your line of sight, because I'm looking at the screen like this. But if the aeroplane flies above my head, I should raise my eyes upwards. So the angle between here and the angle here, that will be the angle of elevation. So the angle between your line of sight and the horizontal is called the angle of elevation. So this is when you're looking at something straight, you're normally looking here, right? But now you're looking at the aeroplane that is somewhere there. So the angle between the angle of sight and the aeroplane you're looking at, this angle in between the angle of elevation. And if you've noticed, you've moved your eyes from here to where the aeroplane is. So you've moved anti-clockwise, right? So that's the angle of elevation. Similarly, if you look down at something, down, right? Down at something, the angle between your line of sight and the horizontal is called the angle of depression. So you've looked something down there. So the angle of depression. So if you notice, you moved from here to looking at something that is there. So you've moved clockwise, which is angle of depression. So these things, guys, it's as simple as that. Let's move. This is as simple as that, and it's not different from the last lesson I did of calculating angles, right? Because I'll show you, I won't spend much more time on this one because it's easy and it's self-explanatory. If you did understand the last lesson, this will be easy for you. Let's take a look at this example. A man looks the thing that sort of like challenges a lot of people when it comes to angle of depression and elevation is they don't understand the statement. So when you read the statement, whatever they tell you in the statement, you draw it up, right? You must imagine what they're telling you. You draw it up in form of a triangle so that you can calculate. Because most of the time they won't give you the drawings, right? They will just give you the statement and ask you to calculate. So you must make sure that the drawing that you draw is correct. Because if it's wrong, your answer will also be wrong, right? So let's look at this one. A man looks out to sea, right, from a cliff top at height of 12 meters. So in simplest terms, there's a man who's standing on top of a cliff that is about 12 meters high. So we've already drew that. This is the cliff, right, which is 12 meters high, right? From this statement, the only thing that is important is this 12 meters and the height, because we know always when we talk about the height, we must go to the y-axis. So it's this vertical line. He sees a boat, right, that is 150 meters from the cliff. It's one, so the man is standing here, right? And this is 12 meters. And then while he's standing there, he sees a boat. Obviously, a boat can be on top of the cliff. The boat is down there, right? So they say he sees a boat that is 150 meters from the cliff. So meaning that from here to the boat, it will be 150 meters. I hope that makes sense, guys. So once you have this picture in your mind, you can see that the only thing left is to join this and form a triangle. Then you're done, right? So we have our 150 meters there, and then we have our 90-degree angle. We have our 90-degree angle here, because you can't have it here, you can have it there, right? And then they say, what is the angle of depression, right? What did we say? Is the angle of depression this angle here? No, right? Is this the angle of depression? Yes, it can be. And in this case, it is, right? I was fooling you, right? Because remember, you noticed how I drew this angle. I drew it like this. I said this is the angle of depression, then I moved from here to there. So I went clockwise. So that's the angle of depression, right? But if you wanted, remember that we said the man's eyes looking horizontally. So we assume the man is somewhere there, right on top of this cliff. The man is somewhere there. So his eyes are looking, if he's looking straight, his eyes are looking somewhere there, right? So if we want the angle of depression, he must move his eyes from looking straight to looking down, because the boat is down there. So if he looks down, then he'll be focusing on this angle. So this will be the angle of depression. Why is this angle and this angle the same? Because if we were to join this, we would have what? A rectangle. And we know that the rectangle, these lines are parallel. And when we have parallel lines, we dealt with analytical trigonometry. analytical geometry, sorry. And then we have this Z shape. We have alternating angles. So if we find that angle, automatically we found that one, right? I hope that makes sense, right? But in this case, we won't be drawing any rectangles, but so you know why we say this angle is equal to that one. So if we know that this angle will be equal to that one, then we can calculate this angle here. We can calculate this angle here using what? Using the concept we learned on the last lesson. We have two sides, right? Remember that the side that is always opposite to the angle that you're given, this would be your opposite side. And then obviously this one, since it's opposite to the 90-degree, this would be your hypotenuse, and then this would be your adjacent side. But in this case, you are given what? The adjacent and the opposite side. So which one among the three trig ratios between sine, cos, and tan here uses opposite and adjacent? That is tan. So tan is given by what? Opposite over adjacent. You see, guys, how these things link. So hence I said, if you didn't understand the concept of the last lesson, this would be difficult. So what is our opposite side? The opposite side is 12. We are given our adjacent side is 150. And then another thing they can trick you with here, you must always make sure that the units that you're given are the same. If they give you meters here and then they give you centimeters, you must either convert these centimeters to meters or convert those meters to centimeters. Your units must always be the same before you can even start with your calculations, right? That is very important. And then from there, you press your calculator, then you get that. Remember that from here, you will take this tan to the other side. So it will be theta is equal to the inverse of tan, right? Theta is equal to the inverse of tan. Your calculator will display something like this. And then in brackets, remember to always close your brackets, it's very important. And then in brackets, you put that 12 over 150. And then the answer that you will get from there, right, you would do something like this, right? Because here, this 0.08 is just by dividing 12 over 150. Then you take this time, you put this in brackets, right? Even if you can skip this step and then from this step, do this right away, right? And then you get 4.6 degrees, meaning that the angle from here to there is 4.6 degrees. Meaning that, in simplest words, if the eyes of the guy are here, he had to move his eyes from here and look there, and then meaning that he only twisted his eyes about 4.6 degrees downwards to see that board, right? So it's as simple as that. Simple, 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 guys. Simple concept. So example number 2, they say that okay, a person walking on open moorland can see the top of a radio mast, right? So this already is an angle of elevation. Why? Because the person is walking straight away on something that is horizontal, and then can see the top. So the clue is always on the statement. Can see the top, right? So he's here, can see something there. So already his eyes are looking here, and then he had to elevate them to see something top. So this is an angle of elevation before I can even finish reading the statement. The person is 200 meters from the mast. So let's say the mast is here. The person is here. From where the person is to the mast, it's 200 meters, right? It's 200 meters. And then he sees something at the top. So this already is a triangle. And then that's your 90 degrees there, right? And then the angle of elevation, you see, they even told you. But before they even told us, we knew already because of the word top. The angle of elevation of the top of the mast is 3 degrees. So meaning that from here to there, the angle in between is 3 degrees, right? What is the height of the mast? So in this case, they didn't give us, okay, this drawing and this one is the same ones, just this one is twisted, right? So in this case, they didn't give us the height, just like they did on the previous example. They gave us the angle and the side. They want us to calculate the height, right? You use the same thing. What is you take the angle that you're given. So the side that is opposite is the opposite side. The side that is opposite the 90 degrees, that's your hypotenuse side. And then the remaining side, that's your adjacent. So what are we given in this case? We have the hypotenuse at the opposite side, which is x, and the adjacent side, which is 200. So which Trig ratio uses opposite and adjacent? That's your tangent. So you take tangent, you write it down, you get a mark for writing this. That tan theta is equal to opposite over adjacent, but we know that theta in this case, remember that theta represents any angle. We do have an angle in this case, which is 3 degrees. So you substitute that 3 degrees there. What is your opposite side? Our opposite side is x. What is your adjacent? It's 200, right? And then from there, what you can do, you can simply divide the whole of this by 1, because anything divided by 1 is that thing itself. Then you can simply cross multiply. 1 multiplied by x is x, and then tan 3 degrees multiplied by 200, as you can see. Then you press this, you calculate this, then you find out that your x is equal to 10.5. 10.5 what? Meters. Why meters? Because they gave us this in meters. Remember that I said your units must be the same. If they give you this in centimeters, you use centimeters. But most of the time when it comes to these things of elevation and depression, they will mostly give you what you have in meters, because they try to take this as the angle of elevation and depression is sort of like we are applying what we learned in trigonometry in real life, right? Yeah. So I hope you understood that, guys. I feel like this is exactly the same as what we did on the last lesson, right? So here the thing is whether you understand and whether you are able to take the statement and picture what they're giving you and throw it out, because it's exactly the same as last lesson's work. So I don't think it will take you time to finish this video to understand, right? Don't dwell more on the examples and everything. You can do those, and I'm not rushing you. I'm not saying I'm sending you the video today and then tomorrow you're telling me that you're done and you understand everything. You must take your time, right? Take your time, but don't be too long at the same time, right? So we send you these exercises, guys, because it's exactly the same thing. I won't bore you with, I won't be repeating the whole thing every day. So the whole lesson I meant to say. So let me quickly discuss this here. Let me quickly discuss this one with you, right? So the sine and cosine rules. What I'm sure you've noticed that since we started with trigonometry, we've been busy with the right angled triangle. So we can still apply the trigonometry concept on other triangles that are not right angles. But other triangles that are not right angled, they have different rules altogether, right? So we can apply the theorem of Pythagoras on a triangle that is not right angled, right? So we have to come up with new theorems, we have to come up with new rules. So that is where we have sine and cosine rule. There's no tangent rule, sine and cosine rule, right? In a triangle ABC, this triangle that we're given here, you must listen to me very carefully, right? And you must not cram these formulas because you'll be given, right? Try to check your formula sheets from previous years and then tell me if you have a formula sheet. If not, I'll give you ways to remember these formulas easily, right? In a triangle ABC, the side opposite angle A is the length A, right? So this, they're just simplifying it so that you understand. This is angle A, right? So the side opposite angle A, they name it with a smaller letter E. The side that will be opposite angle C, they name it small letter C. Same with B, right? Opposite angle B, the side will be small letter b. So we must understand this and have this in your mind to make it easier for you to understand. So starting with the first rule, the sine rule states that the sine of angle A all over A, each side, will be equal to sine of B all over B, which will be equal to sine of C all over C. You don't have to use all three, right? You always need to use two. And what another thing you have to know, it doesn't always have to start with sine A, right? You always listen to me, right? Always it's your, I don't know, guys. I won't write this in full because, okay, it's always your unknown all over your known, right? You don't write this. This is not a formula. This is just a simple way to remember this thing. It's always the unknown over the known. What do I mean? When it comes to the sine rule, meaning that if you're looking for an angle, let's assume that they give you that the angle of that one is 35 degrees, right? And then they ask you to calculate the angle of B, right? Then you know that this side is 4, right? Then let's say this side is 7. Then they ask you to calculate the angle of B. What you will do, you go ahead. What is unknown? What is unknown? Is it the side of the angle? They said angle B, so the unknown is the angle. So you will put the sine B on top. But if the side was unknown, it would be the other way around. It would be A all over sine A, right? It's equal to B all over sine B, right? But right now we are not looking for a side, we're looking for an angle. So it will be exactly the same as here. It will be sine A over A is equal to sine B over B. What is sine A? We know that A is 35, so we'll write down sine 35, right? This would be sine 35 all over 4, right? So let me write it here. It would be sine. But first, before you can even write sine 35, you must first write sine A over A, sine B over B. Then you get your 1 mark, right? So this would be, when we substitute, it would be sine 35 all over, what is the side that is opposite A? It's 4, right? Then equal to sine B, we don't know, it's what we are looking for, right? We are looking for sine B, and then it will be equal to what is the side opposite to this one? It's 7, right? 7. Then from here, what you do, you cross multiply. This multiplied by sine 35, this multiplied by sine B. And then obviously your calculator will give you an answer for sine 35 multiplied by 7, right? So let's say you've multiplied sine 35 by 7, right? Sorry for my handwriting. And then you now want sine, you multiply 4 by sine B, right? It's simple, guys. Basic maths. And then from here, what do? Since you want sine B, you will have to divide by 4 on both sides. So you divide by 4 on both sides, and then this 4 will cancel this 4, right? Therefore, you divide by. So since we want the B, we don't want sine B, we want B. What do you do when you want the angle? You press the inverse. So you go to your calculator. B will be equal to sine, the inverse of sine, and then you open bracket. What do you put in bracket? You put this, exactly see this, and then you find your answer as to what is the angle of B. Then you're done. This guys all reflect to the previous lesson we did. It's all simple. All simple. So they won't ask you to prove sine rule, right? But check on your textbook again. But they won't ask you, right? So we'll go straight to, we'll just go to the cosine rule, which is the last rule. Those are the only two rules. So the cosine rule is a bit complicated, but another thing, remember that I said you stick to your formula, right? So with your cosine rule, you have it's the same concept again, right? You have a triangle, you have angle A, you have angle C, you have angle B, right? And then the sides that the side that is opposite angle A will be small letter A. The side that is opposite angle C will be small letter C. The side that is opposite angle B will be small letter B, right? So when it comes to cosine rule, and another thing, they won't tell you which rule to use, right? Don't be like use sine rule to find this or use cosine rule to find this, right? Okay, before I can even tell you that, please check first before if you have, because like for example, for you to use the sine rule, you must have two angles on one side, or you must have two sides and one angle, right? Those are the conditions for sine rule. Two angles on one side, or two angles on one side, or two sides and one angle, right? Then let's come to this one, right? So for this one, let's say that you want to find the side of A. If you want to find sine A, it will be A squared is equal to B squared plus C squared. This one is more like, almost like a theorem of Pythagoras. But since there's no 90 degrees, but that's how I remember it. It's A squared is equal to B squared plus C squared minus what? Minus 2bc. Why 2bc? It's always minus the side that is your subject of the formula. So in this case, our A is here, so it will be minus 2bc, and it's always 2, minus 2bc, the cos of the angle that is the subject of that. But you don't have to claim this. Remember, I told you that they will give you formulas. For example, b squared, it will be b squared, it's equal to a squared plus c squared minus 2ac, right? 2ac, and then which side is opposite? This one is b, so it will be cos of b. So this one will be always cos. That is why it's called the cos rule, right? I hope you understand how it works, and then we just simplify, right? Just simplify. Let's say, for example, that you are given the side A and B, you have this side C, then and you want the angle. So you write this as it is, you work it out, but you're looking for, meaning that at the end, the whole of this has to go to the other side, and then you should be left with cos A. Then from there, you find the angle. I hope that makes sense, guys. I don't want to confuse you, but this is simple maths. We did an example similar to this one. Okay, let's check something. I want to show you something. What do we have? We have a side. We have a side. We have an angle that is opposite that side. So what do we have here? We have two sides and one angle. What will we use? Sine rule, right? Then we simply calculate this. What is the unknown? The unknown is the angle. So we start with the angle. It will be sine A all over the side that is opposite it, which is 2.1, and then sine 70, side that is opposite it, which is this one. This one is not necessary. This one is not necessary, even if you don't write it. And then from there, what do? You cross multiply. Sine A multiplied by 3.5 is equal to 2.1 multiplied by sine 70. Then you will have to divide by 3.5 on both sides, just like they did here. And then sine, the inverse of sine, you put this in brackets. Then you find your angle, just like we did on the previous example I showed you, right? So guys, I hope this makes sense, right? So let me know if you understand, then I will send you, because if you don't understand, there's no need for me to even go to complex examples. So let me know if you do understand that, then we take it from there. So that will be it for this lesson, guys. Once you're done, let me know that I didn't understand this. If you can repeat this or send me activities so that I can find out whether I do understand or not. But I hope this should be good because, as I said, it's more related to the previous lesson. So yeah, let me know, guys, if you did understand or I should repeat or clarify some of the things. And then yeah, try to hurry.